This is the bit that I learned today. Hi, good evening and welcome. My name's Obi-Wan Piz, and this is Simplex Pachinko, and I have been offline longer than I had planned. I was watching another couple of streams before here, so naturally, I'm a bit late. Okay, so we get up to right, we do the push, come back, do this bit, come out, get into here. Then, like I said, this is the bit that I learned this morning, so we have to wow. It wasn't that long ago. That's the sad part. Let's see, we have to let this one go, come around. There we go. All right, so I'm going to have to turn this way in order for you guys to see anything other than my rear. Quite frankly, not a pretty sight. So this one's going to come out and around. This one's going to come down. What are we doing? Down like that. Come over on the ball of the foot. That's the ball of the foot. And then when we do that, we get down to about here. We're going to take a big step and do a shoulder. No, hang on. From here, I need to go to kind of a, there. Okay. So come over, do this. Then, this is more or less a 45-degree angle out that way. We do a shoulder. Then from here, we're going to put all the weight on the right foot. We're going to turn, and as we turn, we come into a sort of strike out like this. Then, yep. I practiced this like 30 times to make sure that I had it right. And of course, I'm not going to remember any of it now that I don't have my instructor 2 feet away from me. So let's try a couple more times to remember. And if I don't remember, then we're just going to move on. But nonetheless. Over on the ball of the foot. Don't change weight. Don't change weight. So this comes over this way, like that. And then as we shift weight here, right, still on the foot, hit that. Then, yeah, I am completely blanking on this. This is terrible. Hey, Zach, how's it going? Good evening and welcome back. So you're working on your book. How's that going? I stopped over. You know I stopped over. Never mind. Here. Man, that's awful. I'm not remembering any of this. And it was only like not even quite 12 hours ago. Okay. Go from here. Okay, next question, right? I'm on this. Shift weight. As we shift weight, what do we do? Ah, there we go. So we do a roll back into a press, into a push. Of course we do. That's what we always do in this particular situation. Lean back, awkward step again, get back in here to 45 degrees, and then we get into single whip 45 degrees to the back of the room. Then this is where we do one of these things again. Soften the right hand and point straight to the back of the room. And then we step up. How do we step up? How do we step up? Come on, Obi. Yeah. From here, is there something? Yes. There's something to do with this. Come on now. This one comes around. This one comes over. There we go. Okay. So from here, God. We're coming over. We lean back. We come down. Don't do anything yet. Come down to the back of the room. Then we step with the right foot. Where does the right foot go? Where does the right foot go? Forget it. Gonna have to remember on. Gonna have to do it again on Saturday with my instructor. I'll figure it out, but that's gonna annoy me for a while. Alright, one more time. Up until I can actually remember it. Alright. Side G form. Start bear. Push. Twist. Get back around. Single whip. Back over here. Twist around. Settle. Down. Lift hands. Back. Shoulder strike. White crane. Brush knee. That's when we usually go this way because there's more room. All right, brush knee. Step up. Strum the lute. Brush knee. Second brush knee gets us to, right, lean back, come forward 45 degrees. That's where we come through, step, and then punch. Then we tuck, come under, take the place of this one here, and let the right hand slip out, and then go into a push, back, awkward stance, and then we come back around. No, other way. Hang the left on the right. Then from there, right, so from there, that's where we are going to go this way again. I'm terrible. We're going to come this way, turn on the ball of the foot. This comes down, this stays more or less up here. And we do another shoulder strike this way, followed by turn and sort of brush knee. Just let the bottom come out like that. Alright, then, like I literally just did, come on now. I was facing the other direction, which sometimes messes with my head. Right. I have to come up. I have to come up and do a rollback. Press, push. And when we come back this way, go back here into a single whip. Come back through. See here. And again, we're going to, no, here, go about 45-degree angle. .45-degree angle, lean in, and that's when we come down and do 290. Now I'm really awkward on the back foot. Alright, we'll figure that out later. Anyway, how's everybody doing? Hope you're all having a lovely Wednesday. Yeah, it's a Wednesday. For about 10 minutes more for me, but I know most of you are US, so. Okay. So, tonight I was having the thought, it's never going to work, I'm sure, but you know what? Worth trying. So, what I would like to try and do is develop a plan on how to take the research that I've been doing, with Distant Worlds in Elite Dangerous, which is not real, and try and extend it to doing actual research with actual astronomical data in like the exact same sort of way. Now, I don't know if this is already being done somewhere. If somebody has already done this, but I think it would be rather interesting to try and do what is called a stellar density scan. At least in this case, it won't be a scan because we're not literally going there or anything like that. But all right, now the stellar density calculation as given by the Distant World staff says what we want to do find a star, you log its coordinates from Sol. Now, typically, this can be done in multiple different ways. We could do this as polar. So we have the two boo. Yeah, spherical coordinates. Okay, so polar coordinates, generally speaking, given as r theta phi, where that'll make it a little more obvious what I'm trying to do there. R is going to be the angle. No, R is not an angle. The R is going to be the radius to that particular star from our current location, Sol. Theta is going to be the azimuthal angle. Also known as the polar angle, zenith. Okay. Inclination angle, zenith angle, normal angle, or colatitude. Nice. Okay. And azimuth. The mathematics convention swaps the two compared to the physics convention. God damn it. Well, no freaking wonder we're using X, Y, and Z. Not really. Um, so, Distant Worlds is using X, Y, Z coordinates because we have a rectangular coordinate system superimposed onto our galaxy. So, that's just how we're doing it. But that's the kind of idea that we're going with there. Um, I guess that would be positive that way. All right. Well, this one's doing it opposite, so whatever. It's all good. Um, zenith, polar angle. Or the angle between the polar axis and polar line, I believe. Oh, radial line. So I think the biggest problem that I'm going to have just at the outset is going to be to get actual real data. Because I've got a crap ton of data that is in Elite Dangerous, but I don't actually know which ones are real and which ones aren't. I mean, I know many of them that are, but there are many of them in there that are not real. Anything that says, like, you know, HIP, LHS, any of these other ones are from, like, the catalogs, the astrophysical catalogs. So those are nice and easy to get. Right. So the orange angle is phi, and that is going from the positive x-axis all the way around, in this case, to our fourth quadrant, if we're looking in the xy plane. So rotating that polar line around the polar axis this way. So 1, right. Find a star, log its coordinates from Sol. Either A, we could do it with polar, or B, we could do it with rectangular. And that one is just our simple XYZ. Z-axis is again up and down out of the galactic plane, and XY are somewhat arbitrary. I believe Y is positive axis toward galactic center. Could be wrong. And X is going to be positive axis tangent to Sol orbit of galactic center. And then Z, positive axis up by following the right-hand rule. Based on galactic rotation. Now, if any of these are different, then we'd have to go back and revise exactly what that means, but it'd be fine. Right? If researchers collected data differently than I have defined it here, then we go with whatever the researchers defined it as, quite frankly. Okay, so the first thing we do is find a star, log its coordinates from Sol. And then 2, the next thing we do is find all, I guess, known stars, because we can't help the fact that there might be some unknown ones that are just hiding behind others. I don't know, or we don't have the resolution to find them, or whatever. Find all known stars within X light years of target star. And really not just find, but we'll call it enumerate. So just literally count up how many there are within X light years of that target star. This is not too difficult. We just need to figure out some sort of way of calculating. Could also potentially do it as a voxel and like taking a cubical pixel and saying like how many stars are within the cubical pixel that we choose. So, you know, if the distance between that particular star and the star we're at in the X and Y and Z directions are within certain number, then it works. And then we don't have to do a calculation, we just have to compare. So, maybe. Distance. So, we could do delta x squared plus delta y squared plus delta z squared less than x, whatever that number is. Or distance could be calculated as if absolute value delta x is within x and delta y is within x. It's three different logical operator or like logical statements. Well, not just accept, we can, you know, count plus plus. Okay, so enumerate all the known stars within a specific distance, either doing the distance method by the distance formula or creating a voxel distance. Okay, then once we have that, we also want to log if we do furthest, then it would probably be easier to do A. Right, 2A would be easier. Because otherwise we have to figure out a distance anyway. Log the furthest enumerated star. Star's distance. Right, so that kind of eliminates this one as an option. Who's running an auction? Okay, and then 4 There's a formula. Okay. So the one that I have here also maxes out. So that's less of an issue. Okay, never mind. It specifically looked okay. This one's interesting. So, right in elite, max count is going to be equal to 50, because actually, ooh, this one could be a good. This one could be a good candidate. Okay, so this actually could make a good candidate list, because then we don't have to start doing the distance calculation to literally all of them. Right? We wouldn't have to take all of our data for the entire galaxy and be like, all right, of these 50 million stars, right? Or if we are only, we take the database and say, like, okay, only those that are within a certain galactic sector, we're going to calculate those for now. Again, you won't have to take the entire database and figure out what it's going to be for the entire database. You can just do it for that one particular. Hey, Silver, how's it going? Thank you. Could just do it for that sector and then restrict it for the stuff that's within a particular voxel distance, and then calculate the actual distances from that star to all other stars in the immediate area. Okay. So the formula itself is right. Okay. The Elite Dangerous formula gives us that the maximum count that you can have for any particular star is going to be 50, because the radar system that they have, it's not exactly radar, but whatever, the list that they have in your side panel can only have 49 elements in it. So there are at maximum 49 stars listed, plus the one that you are orbiting at that exact moment. So it will max out the count at 50, and then say that we're going to do 50 divided by, this is our row. So this is a particular score that's been developed in order to figure out density. And it is true that rho, generally speaking, will represent density in a lot of physics calculations. So we use this, we go 50 divided by 4 pi over 3 times E6 is the max distance. Cubed. Okay, interesting. Okay. Or it's going to be count divided by 4 pi over 3 times maximum possible distance, which is going to be 20, and then cubed. Okay. So anytime that this is not going to be, this one is not going to be maxed. So we look at the whole 20 light year sphere around this particular star, and then we're going to calculate our density based on the whole 20 light years. However, when it is maxed, then this means that the sphere ends up being smaller, so the density is, the calculation anyway, is going to be higher overall. Why aren't you playing? That's weird. Told you to... Oh, it didn't repeat because it decided that it was... Whatever. Decided it was at the end of the playlist or something. So I actually do like the way it's set up. So say that this is going to be actually, don't put volume there because volume includes the 4/3. This whole thing right here. Right, so it's either going to be x cubed, or it's going to the big x cubed, or it's going to be the maximum distance that we've chosen. So because we don't have a maximum worry, right, we could just use whatever x is, and we can just use whatever the count is. We're not going to end up with a maximum count value, unlike the Elite Dangerous stuff. So since we're doing all this in the computer, as long as we have the correct data for it, then like who cares? It's gonna figure it out. We don't need to. It doesn't need to be anything that we worry about. In this particular case, it's going to be consistent, so, right. Right, we're not going to have a maximum count, so it's all good. Then, after we use that to get all of the individual values for every star, I'd want to colorize this on the density spectrum and, put the, change the color of every individual star, or like a sign. Right, based on the RGB spectrum, single dimension on it, and say that all of the data will be chosen from this particular ribbon of the spectrum. And then we go with the extreme low density. Stars will be blue, and the extreme high density stars will be red into purple into white, I guess, is usually how like rainstorms and stuff like that would work. Could see how exactly that works. So like assign a color based on that stuff, and then 6 actually like display the graphic. The other problem that's going to be in there is that we need to figure out how to store this data in a large enough database right? So we have to have a large enough storage that we could have millions of entries. And we would need to figure out exactly how to do that. So that's not my forte either. Database usage and all that good stuff. Certainly not something you'd want to stick into a spreadsheet. Okay. So again, the initial problem, I suppose, is going to be just where to get all of this data. Internet Stellar Database. Hey, that seems reasonable. Eh. Any of those within 75 light years, anyway. Plus some other known ones that are further. Eh. Even then, I skipped a heck of a lot of solitary red dwarfs for which half-decent data weren't available. Site should probably have a few more goodies added to it in a few different places, but don't let that stop you. Oi. Your visitor number broken. Yep. QPT is no longer working. So, man, since 1999. How to make your own Internet Stellar database. Awesome. Install Microsoft Access 1997. Oh, man. Nice. Stars within 15 light years of 000. Uncle Bill Druin, good evening and welcome. How's it going? It's not that many. 577 stars were found, only 100 displayed. Hey, T-Garden. Stellar data from a variety of catalogs. Current version 2025, containing all stars in Hipparcos, Yale Bright Star, and Gliese catalogs. Almost 120,000 stars, 14 megabytes. Awesome. Creative Commons license. Nice. By SA. I'm not sure what that one is. Share alike. Right. Give appropriate credit. Provide a link to the license. Indicate if changes were made. You may do so in any reasonable manner, but not in any way that suggests the licensor endorses you or your use. Share alike. If you remix, transform, or build upon, you must distribute your contributions under the same license as the original. No additional restrictions. Okay. Hipparcos catalog is, up until the late 2010s, the largest collection of high-accuracy stellar positional data, particularly parallaxes, which makes it useful as a starting point for stellar distance data. Yale Bright Star catalog contains basic data on essentially all naked-eye stars, including much information such as traditional Bayer Greek letters and Flamsteed numbers, missing from many other catalogs. Gliese catalog is the most comprehensive catalog of nearby stars, those within 75 light years of the Sun. Contains many fainter stars not found in Hipparcos. Again, 75 light years. It's really small. Version 2.x of this database contains all stars that are either brighter than a certain magnitude cutoff, magnitude 7.5 to 9, or within 50 parsecs, 160 light years, from the Sun. Current version has no magnitude cutoff. Any star in Hipparcos, Yale, or Gliese is represented. Based on Gaia datasets, also possible. So, okay. I didn't realize it was just literally a CSV GZ file, so whatever. It's cool. Charting the cosmos. Yeah. So I'm not going to actually... Oh, yeah, I will care. I was going to say I don't really care necessarily about the parallax distances, but, like, yes, of course I care about it. It's just that I'm not using it as part of the data because everything's going to be based off of stellar distance to Sol, not to Earth. But that, like I said, doesn't matter. Wouldn't matter anyway because we're doing light years, and being on either side of the Sun is not going to be significant. Bum, 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 bum. 75 might be it, yeah. an ad that goes somewhere else? No. Okay, good. Yeah, never mind. It is ad choices, so. I'm amused. It did not send me somewhere else automatically, so good job. Wait a minute. No, okay. Yeah, yeah. Astronomical terms. Man. Fittings, pipings, and piping classes. Good to know. Ads are about to start. We'll get up, go for a walk, maybe get a snack or something. Bring all this tea stuff back downstairs, and be right back. So thank you very much for coming by. Uncle Bill, if you have any questions, let me know. I, generally speaking, teach math on Wednesdays, but today we're just we got off to a late start and trying to see if I could do something more interesting. So anyway, thank you very much, and thank you to anybody else who's coming in, and we'll see you in about 3 to 5 minutes. So thanks so much. Well, thanks for coming, Bill. Hmm. Yeah, I'd wanted to do astrophysics actually in undergrad, um, or rather, that was my intended master's level goal. Um, and I ended up uh, not continuing a physics major after freshman year, just because I was like, I see that the Great Wall of Thermo is coming up, and like that class has a 39% pass rate. I went, mm, what else do I like? So I ended up becoming a math teacher. Um, have been enjoying it very much. So, and then this there was an event in Elite Dangerous, whose well, the overall goal is just have fun, but there is a sub goal that I joined up. Yeah, I wasn't necessarily scared of thermodynamics. Had I read the book or something, it may not have been so bad. But yeah, that 39% pass rate at my school is just like, mm. I was just thinking back, if it's gonna hold me back from my passion, I don't know if I want to risk it. Which may have also been good because I ended up getting mono in my spring of my sophomore year, so I was just like wrecked. I guess I would have been done with thermo by that point, but there, whatever other classes I was going to take it had the possibility of completely wrecking me if I was also doing that. um. Anyway, how to extract Gaia data? Excellent. How to get star position from Gaia set? Uh, Gaia in the UK. 2 million stars. That's pretty awesome. Data access? Oh no. uh, Yeah, it could have been underpowered prereqs. It could have been that people were just signing up for physics because they were sold on, um, like, oh hey, we have been told by uh, the like one advisor who was also, I mean, she wasn't the only advisor, but she was the one who was sort of like the looking out for the freshmen immediately. That like if you're pretty decent at math and like you're interested in getting a job literally anywhere, you should join up and be a physics major because then like everybody wants physics majors or similar to everybody wants math majors just because you can figure out problems basically. Um, and like, yeah, okay, cool. But if enough people were sold on that, then uh, it could have potentially caused some people to sign up who weren't really committed, I guess. Like I was eh, like I was already reading these pretty well. And when I was, let's see, my parents bought me this on my 17th birthday. Like I was already super interested in astrophysics, and when people were like, "What do you want to do when you grow up?" I was like, "I want to be a theoretical astrophysicist," and they're like, "Holy shit, okay." Everything ends up in Sinbad. Okay. Yeah, I mean that's kind of the problem, right? I don't know what the hell I'm doing. Righto. Well, um, data. That's not really what I'm doing, but okay. I also had a um, uh, who's it? Work study job working on a particular satellite that was coming out of the University of New Hampshire. Um, Unfortunately, I like didn't get a whole lot of direction from the advisor, so like it was like, "What have you done these last 3 months?" I'm like, I mean, I like filled out a bunch of stuff on a spreadsheet that you were telling me about, and they're like, that could have taken you like 2 days. I was like, I mean, I'm in the middle of Calc 1. Like, so didn't work terribly well. They were like, yeah, we need a master's student. I'm like, yeah, yes, you do. Or like, higher undergrad. Had I come in like sophomore, junior year as a physics major, it would have worked great, I'm sure. But as it was, they were trying to hire a freshman to do a much higher level job. I was not prepared. And then like a year later, the project ended up going belly up anyway. So I didn't feel like I was, I don't know. I wouldn't say I was responsible for that. Certainly hope not. Direct bulk download. ECSV, okay. Whew, nice. CSV. Oh. Oh, wow. Holy hell. Also, not knowing how it's like how it's stated here is yeah, yeah. These files can only be considered as a data dump. Uh, fits. Okay. Votable. Interesting. Yeah. Well, anyway. I don't think this is going to help me right now, but could be interesting there. A set of software tools. Asterisk, come here. Monte Carlo marker chain samples from astrophysical parameter interface, etc. scientific community use these new data products. Several software tools have been developed by Gaia Data Processing and Analysis Consortium. Below, a summary of different software tools is provided. Gaia XPY, XP Spectra. Mm-hmm. Oh yeah, that was the other thing was, let's just save this over here to astronomy. In terms of my thermodynamics experience, or rather non-experience, the other thing I was thinking was eventually I'd pop into these and throw those up on stream sometime. Go through them as if I were either a student or perhaps even doing like a study along, that sort of thing. Yeah, because by the time they get to partial differential equations, they've got Brownian movement, laws of thermodynamics, illustrations of thermodynamics, and stuff like that in book 1 of Feynman's lectures. We are unfortunately leaving this place. Probably about 3 weeks. 2.5 weeks. And moving to a different place just across town. So stream will end up being either run on this with phone, or we'll take a little bit of a break depending on how I'm feeling on those particular nights. If I'm exhausted, I'm not streaming. Alright, anyway. So yeah, I'm going to have to look up more information on how to do that. So I don't know if you were here earlier, Uncle Bill, when I popped up with the formula, but the Elite Dangerous formula that we're using for stellar density count was if you have a we have a panel on our pilot's left-hand side which lists up to 49 items, and when you filter out for only give me star systems, then what happens is you get a maximum of 49 star systems listed in your left panel, plus the star system you're in. So therefore, our count is going to be maxed out at 50. Then we say that, okay, we've got 50 systems within this particular distance, which is going to be the maximum distance on that chart. So at the bottom of the chart, let's see, in the Tyroairi sector, which is like on the opposite side of the galactic disk. I took a data set. We go basically once every 50 light years, we take a data sample, and it's what is the number of systems within 20 light years of our current location. So it just scans within 20 light years. If there are more than 50 systems, as is usually the case at galactic disk level, or within one or two readings within that. So up to like 100, 200 light years in either direction. We say that that's going to be, okay, we've got a maxed out calculation. It's going to be 50 divided by, and then the volume of the sphere that we're using. So in this case, 4/3 pi r cubed is going to be whatever the max distance is. So for the first couple, we had within when we were at galactic disk level, z coordinate 0, which I guess Earth is close enough, or Sol is close enough to 0. I don't remember exactly where it is compared to the actual central area of the galactic disk, but whatever. So from a z value of 0, we had a maxed out counter. So we put 50 divided by, and then our r was actually 17.6 light years. So we were only going out 17.6 light years before we got maxed out. Whereas further down the line, we had plenty of these where we only got to 20, or we got to 20 light years before the count got maxed out. So in this case down here, right, when we're not maxed out, we just take whatever the count is and then divide by the volume of the sphere that we're looking in. So that's a 20 radius 20 cubic, no, radius 20 light year sphere in which we're trying to find how many systems there are in order to get our density. It also ignores, if your count is not maxed out, it will ignore the max distance column and automatically just put 20. So we don't want to shrink the volume needlessly. Grok. Oh, you understand. There we go. Yes. I gotcha. Yeah, anyway. So here we're just saying, like,